so I hope you guys had some time to take a look at this. These are the things that we're going to cover, and I got a free response question. There are several people that are putting them together, trying to anticipate what's going to happen for this year's exam. And this, in one exam, is everything that is included, which is crazy. You realize that. This is like the entire course in 2 questions. And there are no functions given. The chart, it's a table, it's a graph. So hopefully you had a little bit of time to look at that. Let me start with this. All right. So one thing I just wanted to make sure you knew, you had that free response packet. That's the only thing I gave you. And so at the end of this class, I need the work for that. Now, if you are still in the middle of doing it, despite the fact that you had a week to work on it, you will have until 5. After 5 o'clock, I won't accept them. And I want you to actually email them to me, because as you email them to me, I'm going to attempt to put them in as quickly as possible. But if it's after 5, I won't accept it. So just so you know. And then I'll put the solutions on Blackboard. Okay, moving on. All right, this is a voting question. There is, above your name, right underneath the talk button, a little tiny check mark. And you can also do an X mark. Let me lower hands real quickly. Okay. So, as we go through these, there are some questions hiding under here. I just want to know yes or no. And this is about scoring. So when they score the AP exam, yes or no, is the statement true or false? Let me just double check. Okay. So you will not be able to see everybody else's responses, just so you know. So you'll only see what you answered, and then we will take a look at it. Okay. First question. If I can move it. Okay. Can you write increasing and decreasing as INC, DEC, instead of the full word? Yes or no? Okay, just waiting for a couple of people to weigh in. Adarsh, waiting for you. June, Nandini. So yes or no? Okay, so here was the answer as far as you guys were concerned. You said, about half of you said one thing, half of you said the other thing. I would err on the side of caution with this and say, avoid it. So the short answer is yes. But I would avoid it if you can, just because you've got the time, you've got the ability. It would be better if you actually write INCREA, like actually spell it out. Okay, so I'm going to clear this. Here comes the next question. Can you write plus or minus for positive or negative? Are you allowed to write plus or minus? I got all these. Okay. Let's see what you guys said. Publish. Okay. So again, it's sort of a toss-up. I would err on the side of caution once again, but I would try not to. Same thing. Try not to. You have the ability to be explicit, and particularly this year's exam, because only have 2 questions, despite the fact that the amount of stuff they cover is intense. All right. I got it. There it is. Okay. Here's the next one. So, kind of hard to see this because it was all squished together. I grabbed it from a text that I got. So I'm just going to outline the actual question. So if you are deciding a particle's speed is increasing or decreasing, you can see it, go ahead and answer it. I'm trying to make it obvious. Okay, so that's the question. If you're deciding a particle speed is decreasing at 1 and your V of 1 or A of 1 value is wrong, but based on that conclusion, would the student still get 1 point? All right. Do the same thing, publish these. Okay, again, I guess it's a toss-up. The answer is down here. I can uncover it somewhere down here. Okay. Oh, that was number 3. If you're deciding if a particle, let me just get rid of this poll. If you're deciding if a particle speed is decreasing at 1 and your V of 1 or A of 1 value is wrong, but you arrive at the correct conclusion. So yes, you would get at least a point for the conclusion. So you get the wrong answer, but your conclusion is correct. But you have to connect the derivative to the position. So if you're talking about A and you say A is the derivative of V, then you're good. So remember, especially because this is going to have few functions on it, if any. So you have to make that connection. V prime is the graph, or F. We're going to have a chance to do that. Okay. Last question. Let me clear these so I know who's doing what. So these are questions that teachers ask teachers, and that's why I wanted to make sure that you saw them. Okay. Same situation. Just go ahead and read that. I think we did talk about this also. So you got this stuff wrong, but then you used it again on the next part. Are you able to get full credit? So let's see what's going on with this. Okay, another toss-up. And you know what's really good about this? I expected you guys to go, oh yeah, blah, blah, blah. And the fact that we're getting a toss-up is fantastic, because that means I made a good call in doing this. Okay, so the fourth, the actual answer is yes. That's this one. So you're going to get credit because you already made the mistake up here. They're not going to take off a second time for it. So usually you have to have said this stuff. You have to have said this. If you don't say this, then you probably wouldn't get credit for this either. But once you say, hey, for example, A, acceleration is the derivative of velocity, you get this thing wrong, so you won't get the answer point, but you will get the justification point. Then you grab that answer from up here, which is still wrong, but you use it correctly for the next part, and the answer is yes. These stipulations still have to be in place, but the answer is yes. So that's actually this one. Okay, questions, problems? Everybody see the distinctions between those? Give me a check mark if you got it. You understand just the idea of what we just went through. Okay, I see lots and lots of checks. That's awesome. All right. So the first one I want to do, and I'm going to put you in groups because if you got here a little bit early then you've already had a chance to observe this. So you already looked at this and you wrote down everything you remember about Euler, everything about mean value versus intermediate, second derivative is improper, Riemann, accumulation, blah, blah, blah. This stuff is, we actually already did this. But in one question, you can have all of that, which is crazy fun. Okay, so let me go to, this is the one I want to start on. Okay. So I want to put you in groups. There are 5 parts, and that means I would like to have you in, let's do groups of 3 again. It'll give everybody enough time and enough practice. And put your name next to the part. So when I put you in groups, actually let me just write that really quickly so I don't forget. So if you're doing part A, now I would suggest that you guys think about this and then do each part yourselves, because sometimes the previous depends on, or the latter question depends on a previous. Anyway, so who's doing what? Notice there's no function, there's just a graph. Okay, so we are grouping groups of 3. We've been doing a lot of review for this, which is fantastic. So we're going to go through this one part at a time, just to see what you guys got. So this first thing, this is a 3-point question. And the first part is going to be L'Hopital's rule. But you have to prove that L'Hopital's rule applies. So you're going to take the limit of the top. So you're going to actually work this out. If you take the limit of this top part, you get blah, 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 0. Notice that this is starting at 2. So if I go to the right, and this is above the x-axis, then that's a positive value. If I go to the left, even though this says area is 2, you're going to the left, and you're going down. So this 2 really is positive because your y values are negative and your x direction is in the negative direction. As we continue on to the left, so I just want to advertise this, it's pretty important. As I go on to the left, now my y values are positive, but I'm continuing to the left. So my delta x's are negative. This is a negative 10 as you're integrating. And then if you continue on, you've got a negative y value. What I was trying to say, okay, so basically you figure out the top, figure out the bottom. Bottom's really simple because that's just a straight up function. You get 0 over 0. L'Hopital's rule applies. This gives you the chain rule. So when you do the chain rule, you get this. You can't stop here because you're asking them to figure out f of negative 4, and they want at least this. You're welcome to simplify it. I wouldn't suggest it, but it's entirely up to you. Sammy, did you have a question? I don't think I can even. So weird. I can't even see your chat. Oh. Exactly. Very nice. So when you're taking limits of functions that are divided like this or can be rewritten like this, if you actually were to plug in 2, which involves integrating and stuff like that, when you get 0 over 0 for your limit, you say, voila, L'Hopital is my friend, I can take derivatives. And you're doing them independently. This is not the quotient rule. Okay. The next one talks about a maximum, absolute maximum. Here your table is sufficient for your work. So you don't have to say, oh, the absolute maximum is blah, blah. What you do is you pick the candidates. Remember, you're integrating from 2 and to the right and the left. So if you're looking for a maximum, this is your derivative. And this side is negative. And then we go into the positive region. So remember we did that. Positive, 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 negative, positive. Terrible writing. So absolute max is where the derivative goes from a, Richard, what's up? Oh, you're just coming in. Okay. So it is where, so at -4, you're going from a negative to a positive. I don't care about the direction. I'm just looking at this as a regular old derivative graph. So -4, what am I looking for? Absolute maximum. So -6 is 1, -4, positive to negative, negative to positive, 0, positive to negative. Oh, they didn't pick them all. Okay, never mind. So you're just picking any place where the derivatives are 0, which in this case is this function. And then you also have to pick the endpoints. So those are your candidates. You get 1 point just for saying, hey, these are points where the derivative is 0. The candidates are -4 and 0. So those are from this thing. So those are 2 things that you need to include, and you need to include the endpoints. So then you work these out. You're integrating, -3. Similarly with this, similarly with this. If I'm going from 2 to itself, I get 0. Yes, you have to show the work as a chart, or the chart as your work. So you can't get away from this. What you don't have to do is explain what an absolute maximum is. You don't have to say the absolute maximum because this is the highest value. I mean, if you're picking the highest value, just hitting 2, then that's pretty clear. Okay? You can say it if you want. That's perfectly fine. But the chart is the money here. You have to show the chart, have to show the candidates, answer with justification. That's a 3-pointer. Yeah. This time I've got from -3 to 1. So from -3 to 1. So from here to there. And it just says evaluate f prime of x. This is an indicator immediately that you're dealing with integration by parts. So you say u is equal to x, because the other one has to be dv, because I'm integrating that. So I don't have a choice. This is u is x. Take its derivative, you get 1. dv is this guy. When you integrate that, you're going to get 1/2 of f of 2x, right? Because the 1/2 is coming from the integral as you're doing a u sub for this. You're kind of doing 2 things at the same time. You're doing a u sub and you're doing integration by parts. Okay. And then it's a matter of it's u times v, ultraviolet blue, so u times v minus the integral of v du, which is this. So that's what this is. U times v, figure that out, minus the integral of v du. And then all of this work, notice you have also within the integration by parts, you probably get 1 point for this part, another point, and I'm just guessing because I'm not sure whether this is broken down this way, but this is going to be a u sub. Work it out, work it out, work it out. You can't leave this part. You at least have to get to here. I would not suggest going on. If you want to, you're going to get -33/4, but otherwise I would not suggest it. Okay. This one was pretty tame. So same stuff applies. The region is the base of the solid. Cross sections are squares. Do not evaluate. This was really nice because all you needed to do is say, okay, well the volume is from 2 to 5 of area of the square is sine squared. Done. So that's the area of the square. And you're doing 2 to 5 because that's what region R is. And then the last thing is series. And notice they say, okay, for x is greater than 5, well, this thing maxes out at 5. So this graph is irrelevant. It's telling you that the derivative is this, and that's also the rule. So we're done with the graph. This is just geometric, and it's a lot of really good work with this. You can pull the -4 out if you want. It doesn't matter. Find the first term. It's the first term over 1 minus r. Just don't forget that -4. And then once you get this, you can stop here. Okay, you don't have to keep on going and give a -8. That is the sum. Okay, if you have extra time and you want to go back, you have a calculator. It's not like, unless you put it in the calculator wrong. But if you're pressed in the beginning, if you have all this extra time, you can go back and work that out if you want. It's entirely up to you. Okay, so let me get a little emotion. You understand what's happening. You get what's going on. We're probably going to go right up to 10:30 today, because I want you to have all the experience possible with these. I picked some really, really amazing problems. I got a lot of thumbs up, smileys. Do you show the work as a work? So when it says find this or show that, I'm not sure what you mean. Can you grab your mic, Sammy? It's a little bit easier. We'll go quicker.
So I mean like So I mean that
you mean this right here?
Yeah.
Are you talking about this guy right here? Well, what it means is either find it, so if it converges, find the answer, which would be this, or let's say it doesn't, let's pretend that this is a 2. So if they gave me a -4 times 2 to the thing, I don't care about that. This 2 is going to invalidate the geometric, and it will diverge. Does that make sense? Any other questions on this? All right. I just want to peek at got really small. Trying to look for the best one. These are all so awesome. Okay. This one will likely be the fastest. So I'm going to do the same thing. You're going to be in different groups because these are random groups. So, and I'm going to give you a few minutes to read this and start working it before you actually write it. So we'll be doing the same thing. I just need to know who's working on what. And groups of 3 means each of you has exactly 1. Okay. All right. We're just finishing this up. Okay, so this first one, and I saw a lot of really great work. Notice what they're asking. So they're saying W double prime of 65. So that's the rate of change. So here you're saying, and of course this is the, what is it? This is just the differential equation. When you take its derivative, you have to use the product rule for this. And check this out. This is a 5-question thing. So find the first, find the second. But if you don't use a product rule or chain rule, you get none of those points. And then this is the rate is changing at the rate of. A lot of times we don't have that. We'll say the amount of workers is changing at the rate of. That would be the first derivative. But double prime means that the rate itself is changing. So you should have gotten something along those lines. Again, you could leave it like this. Not satisfying for me. The second one says, give me that improper integral. You have to use the limit. I was panicking a little bit, and then I saw people putting that in as I was jumping around. So the limit as b goes to infinity. You can't just call this infinity. That's improper. That's the whole point. And then from there, you can use the horizontal asymptote, which is what this is. And you want to say, hey, this is a logistic curve with a horizontal asymptote. In other words, the carrying capacity is 100. And then that means the limit is goes from 100. Okay, I'm going through these quickly only because it's going to be recorded. Was that all you guys had? No. You had the left Riemann sum. So the left Riemann sum, and most people got this correct. Also, this is the average number of workers. So, and you could say 6 and 5/9. You could say 6 and however many decimals 3 places after the decimal if you want. You could leave it like that. You could leave it like this. But the big deal is that you're using the left endpoints for your heights, that you've given an approximation, and then that you're explaining what it is. The average number of workers is about blah, blah, blah workers. And my thought, because I saw a couple of people just said the average number of workers is blah, blah. What I would say, maybe say this a second time. So the average number of workers over from 8 a.m. to 8:45 a.m. is 6 5/9 of a worker. Somebody's pregnant or something. I don't know. So I'd even write that a second time. Okay? So period 1, we are done. Period 3, we're going to be doing some examples that are the same and then some examples we're going to put in that are different. So if you're a period 3 person, there's a whole lot more to this. Notice there's an Euler method part of this. And then there is a mean value theorem 1 and a Taylor. But I really, really wanted to get to this part, improper integrals, horizontal asymptotes. Okay? So if you guys are done and ready for fun, I just want to remind you, if you came in late, then you haven't seen the announcement about the packet, the free response, because I didn't put up an AP question thing. So the free response questions, just give me your work. I don't need the whole packet. If you stuck it in the packet, that's fine too. But email it to my FCPS account, not the FCPS schools. And I'll wait till 5 o'clock because my last class ends around 3, I think, 2:30ish. So, and then once that happens, you'll get the credit for having done it, and then the solutions will be up on Blackboard. Okay, so if you're
Okay, you guys, so we are back together. It's so much fun. All right, so let's go through this little by little. If you like my spring green. So I saw a lot of good work and a lot of good discussion. Like, I don't remember how to do this. Wait, how do you do this? And that's exactly how you learn this. And reviewing is tough. So there's so much involved. So one thing I want to point out is if I'm starting at 2 and I'm going toward the left, these areas will take on a sign. So if I'm going right to left here, my delta x's are negative, but so are my y's. So negative times negative is positive. When I get to 0, now I'm going in a negative direction on the x, but my function is positive. So negative times positive means that this 10, as an integral, the signed area is negative 10. And then as I continue on this direction from here to here, I'm still going, my delta x's are still negative, my y's are also negative. So these are rectangles, so base times height is negative times negative is positive. And then, of course, if I go this direction, but remember, I'm starting at 2. I'm not going all the way from the left to the right. I'm starting at 2 and I'm going left or going right. So just bear that in mind as you're doing these. When you're doing limits, so this goes all the way back to first quarter. Because as you're doing limits, the first thing you do is you try plugging that in, right? So I'm going to plug in negative 2. I'm going to get g of negative 4 minus negative 4 times negative 2. So g of negative 4 means start at 2. G is an integral. Start at 2 and integrate all the way backwards to negative 4. So this top part gets worked out. The bottom part, same thing. Plug in a 2. You will notice if you do that, that you get the famous 0 over 0. So you wind up with this. And that's fantastic. That's something about which you jump for joy. So L'Hopital's rule applies. And I can carry on. I'm going to differentiate this independently, right? You differentiate the top independently from the bottom. So g of 2x is now g prime of 2x times its derivative, chain rule, minus 4, derivative of 4x is 4. 2g prime. Well, g prime, remember, is this graph. This is g prime, because if it weren't, then this wouldn't be true. So f of t or f of x is the derivative of g. So you're just reading the graph at this point. And then, let's see, g prime of negative 4 is 0. And then the bottom, e to the 0, which is what this guy is. And then 2 times negative 2, which is negative 4 plus 1. And you wind up with a lovely fraction. Now, you can't leave it in the form that it's in right this minute, but I can leave it in a non-simplified arithmetic form. So that's what I'm talking about. You can stop here if you want to. You can't stop here. So you have to have all numbers. If they can't just do arithmetic, if you can't give it to your second grade brother and they can do this, then you can't stop. So if you had sine x, you couldn't give that to your second grade brother. So, or maybe you could, I don't know. You guys are pretty smart. Okay, so the point distribution for this. You get 1 point for recognizing L'Hopital's rule. The limit of this, g of x minus 4, this alone gets you a point. So, apply, okay, and then the final answer, which could be left like this. Okay, so let me get a little emotion. You get what's going on. You see what you could do, should do, did do, something. You say, yippee, yippee. We love math, we love math. Math is fun. Fun math. I feel like I'm missing conversation down here. Okay. So Braden, you just, yes. You take the limit. No. You plug the negative 2 in. So if that's what you mean, yes, you're going to plug the negative 2 in, see what happens. If you can do it, anytime you're doing a limit, plug in the value in question. If you get 0 over 0, that's cause for great excitement because then L'Hopital's rule applies. Then you differentiate the top completely independently from the bottom. This is not the quotient rule. And then if that still results in 0 over 0, you do it again until you get a value. Okay? I saw a lot of good news. Okay. Second part. Absolute max, absolute min. Those are y values. They're y values. They are y values. And when you're finding an absolute max or min, you look for critical numbers and you look for endpoints. So critical numbers on this are going to be negative 4 and 0 because that's where the derivative of g, namely f of x, is equal to 0. And the endpoints, which is f of 6 and then f of 2. So that's the first thing you do is identify them. And this is really, 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 really important. Somewhere you have to state the g derivative. So g prime is f of x. That's telling them, hey, I get that this graph is a derivative. Therefore, when I say critical numbers are negative 4 and 0, it's legit because derivatives equaling 0 produce a critical number. So you have to state this someplace in the question, even if at the top or somewhere in part A you say this, just somewhere say this so that that justifies this. Simply giving it for this question won't be sufficient. So identify the critical numbers, identify the endpoints, which is what is hiding under here. That's what I said. The rest of it is, can you do a derivative? Can you integrate? So in order to get to negative 6, the value at negative 6 is, well, start at 2, integrate to negative 6. If you're correct, you're going to get negative 3. You're just counting area. Go from 2 to negative 4, come up with that area. That winds up being negative 8. 0, 2 to 0, winds up being 2, because they told you. And you're going backwards, and the thing is down. And then if I go from 2 to itself, I have nothing. I've covered no area. Then you look at these y values and you say the maximum is 2. If they ask you where it is, you can also say where x is equal to 0, but your answer is not 0. You do not give this answer. You say, hey, my maximum I know is a y value. It's a function value. So you would say the absolute max. This is your work. The chart itself is your work. You don't have to go through and say, oh, by the way, a maximum means big. You don't have to do any of that. You don't even want to do well, you can if you want. You can do a number line, but they won't look at it. They won't consider that. They want to see, have you identified critical numbers and the endpoints, and then use those to calculate the biggest or smallest number. So that's the rest of it. So you have to say G prime is 0, i.e. this connection has to be made. You have to decide that the candidates are -4 and 0, so choosing those two. And then also you have to use the endpoints and then answer. Okay. All right. Let's check this one out. This one, and Raghu, I was in his classroom and he has a fantastic question. He said, well, I don't know the function, which is exactly what it's going to be like. Like the ILate thing is totally useless because I don't know what these functions are. So the question is, this has to be integration by parts. I've got two functions, they're multiplied, and there's no way for me to take the derivative of 2x in here and use u sub to get x. That ain't happening. So you would say, okay, well, I have to take the integral of something and the derivative of something else. So I'm going to let u equal x. I'm going to let dv equal f prime 2x. Because the integral of this is this graph. It's the y values on this graph. So, and I'll have to do a u sub for this. So setting that up. There are the u's that I just got through talking about, u and dv. This is ultraviolet voodoo. So you're saying if I want to integrate this, this is u times v minus the integral of v du. du is just 1. So the integral of v du, you get the 1/2 because of this. After that, you can work out this part, and then here is where you have to do a little baby u sub, the old-timey cat burglar u sub. And then you can work that all the way out. So your final is -33/4. I always advertise and promote stopping as soon as you just have arithmetic. And then the point distribution for this one is hiding. So you get 2 points for doing the integration by parts. And then you get 1 point for your answer. So if you don't recognize this as integration by parts, you've lost that. Well, you've lost your answer also. So, okay. One more part. This one is a fun one. Did you have fun with this one? This is just a region that has squares. You know that you just grab the area of a square, side squared, and they just want a setup. You can't evaluate it anyway because I don't know y values on here, but I can set it up and say, okay, you guys, if you know this stuff, you can do it. So all you do is you say, well, volume is side squared. This region, what you don't want to do is put r squared or r. You know, like r is this area. You don't want them to have to make the leap that you understand what r is a function of. How did you get it? So this is side. The side is this function. And then side squared is the area of a square. Integrate from 2 to 5. And of course you can't work that out because you don't know specific values. I think that's just a 1 point. The last one. So look at the way this is worded. And Shrey, did you have a question? Your text box is lit up. I just noticed that. I don't know if you've got a question. Oh, okay. Okay. So check this out. This says for x is greater than 5. Okay, so here's 5. I have nothing greater than 5. So you're saying, okay, this probably has nothing to do with that graph. They say f isn't given, but f prime is given. Okay, great. So here's f prime. And then they say, hey, there's a rule where f prime is a rule in a series. So all the rest of this is completely irrelevant. They could have said an is this and moved on. This would be kind of a confusing thing because you're thinking, oh, it has something to do with the graph. It has nothing to do with the graph. All you're doing is looking at this, and I saw fantastic work. You recognize, hey, that's geometric. And it converges, so you give that answer. Probably in this form, you could stop right here. So either give me the answer or show that it diverges. So had this been 2 to the x minus 5. You would stop and just say, well, that's geometric. Ratio is greater than 1 diverges. So that would be the showing part. Like you have to justify that somehow. And then that's it, just 2 points. Okay. Why do I not put R? Because you're making them, you're assuming that they understand that R is an area. Because R is an area. You're not squaring an area. Right? You're squaring the values of this function. Does that make sense? So you don't want to do R squared. You want to say, no, I'm taking the values that vary as this function gets bigger and bigger and bigger and smaller to 0. Whatever those are, I'm squaring them because I'm doing sine squared. Great question. Anything else? Is everybody okay? Give me a check mark if you're good. Little green check. Checktastic check. Checkorama. The checkster. Aaron, are you doing okay? Yeah, Isaac, this is going to be up and it's going to be compiled. I don't know if it's going to be this specific one, but in my first 2 periods, I did different examples, which is really good because then you get the whole thing. And this key will also be up. Beans are cool. Aaron, are you there? I want to give you credit for this. We're doing check marks. I want to know if you're okay. So just give me a check mark if you're okay. That's all I need. Okay, beautiful. All right, so let us forge ahead. This class is probably going to go about another 15 minutes or so. And then we must stop because math is so much fun. I can't stand it. All right. So, Isaac, you inspired me. You said, I don't remember Euler's method. Many people don't, but it's a really simple thing. So what I want to do, once again, is give you some time to think about this. Consider this. I realize we're starting at D, and that's on purpose because the other stuff, we'll get to it. We'll likely get to it. We covered it in a different class, and Euler is something that you haven't seen for a while. So I'm going to put you in groups. They're random, so you're probably not going to be with the same people, which is good. Got to mix it up. So I'll do that, and then I'll shoot this page to you.
Recording stopped.
I did the word used. What? What were you talking about? We had like on the Hercules the other day. I had to do that in classes. They don't take that long, does it? Alright, which ones do you want to do?
interested in mine is like it's one of those theorems that we learned at the beginning of the year, but I forgot which one.
Mean value theorem?
I think that was one of those.
Welcome to the Audio Setup Wizard.
Hello.
Hello.
Two. What? So we put it. We put in 65. 60 times no. We put 60.
Recording started.
Okay, you guys. Saw some amazing work. Great discussions. That is half the battle, is being able to discuss this stuff. Okay. Let's see what's going on with this. First thing was Euler's method. So Isaac, hopefully your memory got a workout. Some good jogging went on. So, I bet you're writing something. All right. So Euler's method. Remember, that means you are... Actually, I can just remove this. That's fine. So now you're estimating. You're going from 45 to 85 with equal steps. So that means 45, 65, 85. You've got a delta x of 20. So this is m delta x. And you figure that stuff out. So, and your dy dx is right here. So m delta x. And then that gets added to the y value. So you figure out the derivative, multiply it by delta x, add whatever that is to the previous number, and you get the next one. Similarly, now you're going to use this for y, work out your m, multiply it by delta x, you get this, which then gets added back to 58. Done. So we don't have any information over here, but if you were to use that, that would be an approximation given that function. So Euler's method, knowing it, and the approximation that you get. Done. The next one, it's so much fun. You don't need to round. We don't need to round. Wait. You should round to 3 decimal places. Oh, you don't need to round even when it's people. Please don't round, even when it's people. So the only time that you would want to round is if they say round to the nearest person or round to the nearest tenth of a cent or round, do you know what I'm saying? But don't round anything. When in doubt, just leave it. So, great question. I know we talked about that, but it's been so long. Holy cow. Cows are definitely holy. Okay. I need my spring green again. Okay. Okay, that's not so springy, but that's okay. All right. So here, and I heard some good discussion about this too, is there a times c such that the derivative is 1? What theorem did you guys use? You can just scream this out. I don't need to wait. What theorem did this involve? What were you doing for that? Wow. Okay, so IVT, no. You want to talk about, because you're dealing with the derivative. So you don't want IVT. You want the mean value theorem. Intermediate value theorem is the balloon problem. So you're standing here, you want to know if it got from here to here. Okay, mean value theorem is the one that you want because you're talking about a derivative being a particular value. So if you find the slope on this interval, and that's equal to 1, then there has to be some place, given the fact that this is a twice differentiable function. And that's important because differentiability is required for mean value theorem. So, and the twice differentiable is important for the next part. Anyway, so there you go. Find the slope. y2 minus y1, blah, blah. You find out that that is 1. If that's true, and this is a differentiable function, mean value theorem will guarantee another place, some c value, at which the derivative of the actual function is equal to 1. So you have to say mean value theorem MVT is standard. You don't have to write it out. And you have to show that you understand this is this average value, the slope, has to be the same as that derivative. So 2 points. I think there's just one other part, D, E, F. Okay, in this one, people rocked it out. I was watching this. So second degree Taylor. So we're looking at, blah, blah, blah. Use it to the, blah, blah, blah. Okay. So you start out with what's happening at 65, because you're starting at, 65 is your center. So W of 65, that gets you right here. And then the derivative at 65, the second derivative at 65. So And you know what the derivatives are because you have the first derivative. So the idea is use this for w prime, take its derivative, use that for w double prime, and then build your polynomial. When you're done with that, you plug in 85, that's where the 20 comes from, and you could leave this as a fraction. I would stop right there. You do the math, people. I know you can do arithmetic. I did the calculus. If you want to, you can stop there. If you really, really must, you can carry on. So that's 3 points. Okay? So give me a little emotion. You're still awake. You're still alive. You're remembering, like maybe kind of, sort of. Yeah, I kind of remember this, Miss Rubin. You realize 2 weeks from today-ish, you're going to be testing. So, oh, Rachel, no, it won't be Rolle's theorem. I'm glad you asked that or said that just now. It's not Rolle's theorem. In fact, lose the idea of Rolle's theorem in your head. Nobody cares about Rolle's theorem. Rolle cares about Rolle's theorem. But you don't want to use Rolle's theorem for this because that would mean that the derivative is 0. Right? That would mean that the rate of change would have to, the average rate of change would have to be a 0 slope. That's Rolle's theorem. So you don't want to mention that. Don't ever mention that. It's just a special case of mean value. So I'm so happy that you said that. So happy. For the exam, I saw there were 2 dates. Can we just choose to should? I don't think so, Isaac. From what I understand, unless they're extenuating circumstances, they want you on that actual day. Like if, I don't know, your mother has COVID or something like that. But to my knowledge, you are supposed to do that first date. And then you can contact them if something crazy is going on. Okay. So what we did in the other class, and I'm not going to do that with you guys because it's already recorded and it'll be canned and put up. And I'm having issues with the YouTube site. It keeps telling me that videos are too long, blah, 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 whatever. I don't know. I can put some up and not others. So I'm just saving them. I'm editing them in a different software, saving them to an MP4 and putting them up on Blackboard. So anyway, the other stuff that was part of this question, the ABC part, was finding derivatives and then explaining what it was. This is like that Hughes Hallett stuff we did, like W prime. That's terrible. W double prime of 65 means the rate at which the rate of change is changing versus W prime, which is the rate at which the workers are changing. This improper integral, we talked about that. So that's why I didn't go into this, but you definitely want to try this because it'll give you practice. Notice how general this is. Crazy general. Because it's W prime of this thing. Who knows? And then left Riemann sums, we did trapezoidal rule the last time. Left Riemann sums, 3 subdivisions. This shouldn't give you a whole lot of trouble. And like I said, I will have the answers to this entire mock AP up. And the recording will be up. And with other examples. So I am done and ready for fun. I'm going to quit recording. And goodbye, recording people.
Recording stopped.
Okay, for those of you who are listening to this, watching it, these are examples that I used in my 3rd period class, which are different from 1st period. So I'm picking up where the new examples begin.
Okay, so my other class we did a different problem. I'd like you guys to work on this one, and then if you want to go back and you want an explanation for the other one. But I'll do the same thing. So you won't be writing for the first few minutes. This is actually a relatively quick one, and we may be able to go back and do the previous one, which was done in the previous class. Okay, so we have 21 people here. We'll go into groups of 3, but then some of you I'm going to move so that you're not in a group of 2. Because I'm not included in the group. Okay. All right. I'm going to breakout rooms, and then we'll come back together. Steps. So you're starting at 45. You're trying to get to 85. So the step must be 20. So 45, 65, 85 is your goal. And then these are your Y values. So 30 is coming from here, 60 is coming plus 28 gives you 58. Repeat the process, you get 32.48. Add that to 58, and you get 90.48. So 2 points. Did you do Euler's method, and then what's your approximation? My guess is if you did Euler's method, but you did some weirdo thing, so the approximation wasn't right, you would still get 1 out of 2. And then E and F. So is there a time on 2545 when the derivative is 1? Well, that's the mean value theorem. So you find the derivative, the average slope, average rate of change. So it's just f of 45. This is y2 minus y1 over x2 minus x1. That rate of change averages 1. So there has to be a time, and you want to really write this all out. So WT is twice just differentiable, which means this has to be continuous. So remember, mean value theorem says you got to be continuous. And yes, and therefore there has to be a time t between blah 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 and blah blah blah, 25 and 45, where the derivative is 0. Where the derivative is equal to 1, which is the average rate of change. Second degree Taylor, you guys rock this. So you take the first w at 45, first derivative t minus 65 at the first, second derivative over 2 factorial t minus 65 squared. Stop because it wants the second degree. And then it's asking it to find the number of workers inside the building. So you are going to P2 use it to inside the building at 925. So t equals 85. So you didn't have to figure that out. You plug in 85, and you're going to get 87 point blah blah blah. Of course, you can leave it here. You don't want to leave the factorials in it, but you can stop right there. Okay? So let me get this. If you are good to go, then just give me a check mark, because then those don't disappear for me. So just a check mark saying yay, or I don't know, boo. You do an X mark for boo if you want to say this. So just wait, make sure everybody's doing okay. All right, Nav, are you doing okay? And Ray and Richard and Sam, we're just putting up check marks if you're doing all right. Yay. Okay, well, I'll hang out for a little bit after this in case you have any questions.